So we're going to take a look at graphing inequalities on.
Okay, so we're going to use a couple different vocabulary words attached to some symbols when we're doing this. So just going straight down, we're going to use less than, so this is our less than symbol, and greater than, that's our greater than symbol. And then when we put this line underneath, that adds an or equal to portion. So less than or equal to, greater than or equal to. And then lastly, we have this new symbol, an equal sign with a slash through it. This is not equal to. Okay, so when we're graphing, we're talking about real numbers unless otherwise noted. So we're talking about numbers that can be plotted on a number line. So when we're graphing, all that we're really doing is we shade all the real numbers that make any given inequality true. So we need to remember a couple of things when we're doing this. So if we're plotting something like x equals 5 on the number line, right, we've done that before, we just go to 5 and we kind of shade it in, and we shade it in with a little dot. If we then wanted to graph that it does not equal 5, then all we would do is that we do not shade the circle. So we would just leave it as an open circle instead. Okay, so let's take a look at some of these inequalities here. So we have a few of these inequalities. We read inequalities traditionally left to right. So if we would read this first one, we would read this as x is less than 5. So when we go to shade this, we want to think about shading all of the numbers that make this true. So I could plug in a 4, a 3, a -10. All of those numbers on the left-hand side would be perfectly fine. They're numbers less than 5. The one number that I really want to make sure I don't use is if I put a 5 over here, right? That doesn't work. 5 is not less than itself. So we want to make sure that we don't include 5 in this shaded region. But we are going to start our graph kind of at 5. But in order to tell whoever's looking at your graph that 5 doesn't actually work, we're going to put a little open circle right at 5. We can get real close, right? We can be 4.9, 4.99. Those are all less than 5, but just not right at 5. And then we want to shade the side that has the numbers less than 5. So we said that was like 4, -10, 3. So that's all the numbers over here, and we're just going to draw a line and put an arrow because we can go as far to the left as we want, right? Even -1,000,000 will work. So now our next inequality, x is less than, and now we have this little line underneath. So we have or equal to. So what this does is it tells us that now we can put 5 right there, right? Because 5 is equal to 5, but we could still put all these other numbers, 4, 3, -10, 2.5, anything like that will work over there. So the difference when we go to graph it isn't very much. We're just going to, this time, shade in that circle saying, hey, 5 is now okay, and so are all the numbers less than it, so to the left there. All right. Now we're looking at x is greater than 5. So we want all the numbers larger than 5. So 10, 20, 66.8, anything like that. But similar to the less than, when we have greater than, we can't put 5 there. 5's not bigger than itself. So when we go to graph this, we're going to use that open circle, and then we're going to shade the numbers that are larger than 5. So 6, 7, 8, and all the way to the right. Okay, now this next one, x is greater than or equal to 5. All right, quite a bit to fit in that little space. So again, the only difference here is that now putting 5 in that spot is okay because we have that or equal to part of the phrase, and 5 is equal to itself, 5. So now when we go to graph, we can put our filled in circle and also shade all the numbers greater than. So they're all the values that are going to make that inequality true. Now let's take a look at reversing this process. So instead of being given an inequality, what if we're given a graph? So one thing we noticed above is that the dot is always on the value that is displayed in the inequality. So here, the inequality is always, less than 5, less than or equal to 5, and our dot is always on 5. So when we start to write these on the right-hand side, it's just going to be the value where our dot is, whether it's an open or closed. So for this first one, we're just going to have x on the left-hand side, just like we had all of those. So x is just standing in for, we can often say, all the numbers. And then all the numbers, some inequality, and then the dot is at -3. So we have to decide which inequality describes where this shading is. So all of these numbers that I see here on the side of the shading are all larger than -3. So I'm going to use a greater than symbol. And then this is an open circle, so it can't be equal to. So I'm not going to put the equal to sign. All right, we're going to start number 6 in a very similar way. So all the numbers, some inequality, and then 6, right? So x is just representing all the numbers that are related in some way to 6, okay? Now, if we look at the shaded area, these are all values larger than 6, so we know that we're going to be looking for all the numbers greater than 6, and it's shaded in, so we could also be equal to 6. Next up, all the numbers some way related to, our circle is at 2. So if I look at my shaded region, all of these numbers are smaller than 2. So we're looking for all the numbers less than 2. And this is an open circle, so I'm not going to put the or equal to part. I'm just going to leave it as strictly less than. Last up, x, or all of the numbers are related in some way. Our dot is at -4, so we need to determine that relation. Okay, so here our shaded area is all the numbers that are less than 4. And we do have a closed circle there for -4, excuse me, so we're allowed to be equal to. So all the numbers that are less than or equal to -4, those are all the numbers that we're looking at here in that graph.